Hope coffee was good. And hello, everyone. My name is Gürol Akman. I'm the CTO at Telenity. Telenity is a company that is in telecommunications business, that has been in the telecommunications business since 2000. So it's over 20 years. And we are active in over 30 countries and 40 plus operators we do business with, and we serve to the needs of over 1 billion subscribers. If you look at our footprint, essentially, actually, I will come to that in the next slide, but let me tell you a bit about the structure of the company. We have 4 different offices, and the headquarters are based in Connecticut, USA. That's where I'm based at. And we have large presence, our R&D offices, as well as other engineering operations and sales and everything else in Turkey, Istanbul. And we have, again, a large presence in India, in New Delhi. And also we do have an office in Dubai, United Arab Emirates. We essentially have 2 main product lines and a third one that feeds both of them. And these product lines are referred to as the Digital Services Platform, which is actually a service monetization platform which exposes what an operator has in form of charging as well as service subscription capabilities. And it exploits the relationship, the trust between the operator and its subscribers to offer services such as direct carrier billing, as well as it offers the means for paying for digital services and digital content with very flexible charging models, whether that's micro payments or partial payments or other forms of payments. However, today I will largely discuss about our VAS consolidation platform, which is what this journey is about. And it is a journey that's slightly different from what it could be, because it is not a NFV-based deployment from get-go. However, it is more of a evolution of a virtual deployment into a VNF-based deployment. So in that sense, it presented some unique challenges that we had to deal with, and I'd like to share these with the community in slides to come. A great majority of our business is with mobile operators, although we do have some fixed line operators, and we also do some amount of inter-operating platform and service offerings. Our business models primarily are either license-based or, in certain places, we also deploy things and we operate them in the form of managed services. And there's a great deal of operator places where we do rev share-based business. This is another shot at the current product portfolio we have. The digital services platform essentially exposes a whole bunch of things through an API manager and a convert services platform and direct carrier billing, as well as service subscription management and payment. Those are the pillars of that solution. And also they come in addition with advanced analytics, as well as business intelligence and storefront capabilities. However, it is not in today's discussion. The VAS consolidation platform is definitively in center stage, and it essentially comprises a whole bunch of core messaging products such as SMS Center, MMS Center, USSD Service Center, and a whole bunch of mass media appeal services such as missed call notifications, such as collect call, mobile collect call, or voicemail, or roaming services, as well as some ringtone service and like. And the location-based services and platforms are also an important pillar, mostly for enabling what's above in the form of location capabilities. Yes, we do have, some very location-centric platforms and deployments, and also some verticals, both in enterprise as well as in consumer market, to have location-based services such as enterprise resource tracking or some safety features that actually tap into the location of the subscribers. However, we typically use this to location enable our digital services platform as well as our VAS consolidation platform. So that's why it's not listed in the first slide, but shown here. This is a partial look at our customer base. We have a lot of presence in the Eastern Europe region, in Southern Europe, as well as obviously in Turkey. We do business with all three operators in the country, and we have a very large presence in the EMEA region, in the Middle East, as well as in Africa, and also in Asia. And these are some of the operators that we do business with. Again, it's a partial set, but I think it's a good representation of who do we do business with. Now, I like to come to our NFV experience. I think that's just a statement that we would like to make where we have started, and just to give an idea as to how far we have come. Obviously, it's far from being complete. However, I hope that it gives us enough credit or qualification to speak in such a wonderful occasion. We have done some preliminary work forward to 2017. However, our actual engagement with NFV started in year 2017 and continued all along and continues still as we speak. Now, the former phases of our NFV involvement really started through some funded research activities. TDEP and HTK, those are parts of consortiums and some organizations that do provide technology and innovation grants, and they combine academia as well as industry and government units, and they essentially support industrial research and development for especially new technology and new product introduction. So with that in mind, we started in a 2-year project as part of the TDEP NFV, where we have done funded research to investigate in general the NFV environment, but in particular the MANO block in terms of VNF management and NFV orchestration. So this is a place where we have installed a plain OpenStack platform in our lab. And at that time, we started with Okata release. However, then we progressed into Queens and Rocky all the way. And dating back, we started as early as release 4 and release 5 of OSM, and then followed it through to release 9, and I think ongoing release 10 discussions today. Now there, essentially, to become familiar with what ETSI had and what the industry had in place, both in the form of open source as well as in a commercial sense, we have evaluated all the way from the specification compliance perspective, how well they comply with the feature functionality that is slated for MANO components, as well as how the packaging should be done, how the API exposure should be done, and how the VNF or NS modeling, as well as the descriptor languages have to be used. So we started with all these details, and then at hand, we essentially had open source MANO in one place. And then on the side, we looked at other solutions, including OpenButton and Tacker, as well as then we started looking at different commercial components. Now, starting with year 2019, this time around, there was an end-to-end 5G initiative, supported and promoted by a consortium, including TDEP, ETK, OSTIM, several other in-country units. And this is, again, a 3-year funded research project where we had done business or collaborative work with all 3 in-country operators, that's Turkcell, Türk Telekom, as well as Vodafone, plus over 15 different vendors that cover all the way from CRAN into core 5G, all the way up to VNF management and orchestration, as well as OSS, security, integration, and up to all the way to the VNF and NS provider space. So this is an ongoing activity. It is still, funded through the end of this year, and this is where we've been exposed to a greater variety of VIM providers, NFV infrastructure providers, as well as many variants of OSM. Now, Also in year 2019, this is where our first engagement started for a commercial opportunity to deploy an NFV-based VAS consolidation platform. And as we speak, this is evolving into some commercial opportunities, and the variety is increasing, where we are supposed to make use of the vCloud as opposed to RedHat OpenStack platform, which we leverage for that commercial opportunity that I will speak about. And I think there's upcoming opportunities for either upgrading what we have from RedHat OpenStack 13 to 16, or essentially leveraging vCloud as the NFVI infrastructure, as well as making use of bigger and better releases of OSM. A few words about VCP. VCP stands for VAS Consolidation Platforms. It's a flagship product of the company, and it has a number of benefits in terms of reducing the CapEx as well as the OpEx for operators with a smaller footprint and lesser license cost, and improving the time to market for new services or for prototypes or anything else. It provides a great deal of operational efficiency, and it strives to make the complex life of operators as simple as possible. At the same time, it tries to provide a lot of flexibility, both in terms of scalability in and out, and as well as utilizing concepts such as unified licensing, which allows operator to make use of a unified licensing unit to manage their license quotas across an array of products in a very flexible manner. Otherwise, normally, each product would be licensed at its own, and then, if a product is doing better and then needs to be scaled out, it would require additional, license costs. With the flexible licensing model, they can use the licenses they have in any direction that they choose, by increasing or by decreasing or by deprecating parts of it. So this is the platform that I will talk about today. And, our website, as well as us, will be happy to provide more information to any interested parties. But looking at the packaging of the VAS consolidation platform, it actually contains a whole bunch of core messaging products, as you can see on the side screenshot here, from SMS Center down to the USSD. And then also, handful of services, which numbers is increasing as we speak, because it is not only our services, but also third-party services, which are welcome on this platform that we have built. This is a snapshot of an initial VCP deployment at this particular customer. Now, I think the key things about this slide is that there are two physically separate, however, content-wise fairly equivalent, capacity-wise fairly equivalent sites. They are geographically, redundant sites. And the traffic patterns, there are slight differences between what is received through one site versus the other. However, they operate in active mode. And then, essentially the platform comprised initially from 10 different blade servers powering the NFVI infrastructure, some shared storage, as well as some local storage on each one of these blade servers. On top of that, we essentially started with about 80 virtual servers per site. I think this is a place where I like to underline the fact that the initial deployment of this platform was purely in plain virtual form, that underneath it was powered by KVM and Camel. However, on the top, plain virtual machines were being used to deploy our services. Now, over time, this platform will evolve more into an NFV infrastructure, and then will be governed by OSM. However, we will see that, but that's an initial snapshot of what we started with. Some specifics about the NFV infrastructure. From NFVI perspective, we leverage RedHat OpenStack distribution 13, and then it was essentially, it comprised around over 1,000 virtual CPUs, over 3.5 terabytes of RAM, and quite a bit of local storage as well as some shared network storage, and all was based on RedHat 7 release. When we speak about the MANO component, and in particular OSM, OSM was housed in a separate virtual machine, and there we leveraged the OSM release 8. Our experience was all the way from, as you remember, from 4 to 5 and on. However, we came to a quite good understanding and hands-on experience with release 8. So that's what we leveraged in the field. And this was deployed separately in the form of a VM, and it contained 8 virtual CPUs with 16 gigabytes of RAM, only local storage. We didn't need more. And then we leveraged the Ubuntu as the guest operating system. And I think to the right of the slide, you see the infamous ETSI picture as to RedHat and Open Source MANO powering this platform. Now, this is a place where I show some of the cables, and please forgive the blurry pictures. We wanted to blur parts of the critical pieces of data for confidentiality and privacy purposes. We thought it's only appropriate. However, some details here, we bring them all the way to the front here. And one of the things we bring to the front is the network topology. Anything and everything that you see here in the forms of color bars here were predefined. And that exposed its own challenges, which we will get to. Except the one on the way right, which is the internal OSM network that we have deployed later, just to be able to transition from the VM-based environment to a VNF-based environment. However, everything else that you see there essentially were there, some of them being provider networks, some of them are being tenant networks, and some of them are being just internal management networks, just as part of the virtual infrastructure. Now, when we were making the initial deployment, I'm guessing that most of the audience is familiar with concepts such as host aggregates or availability zones and how they tie into the compute flavors, because those are the key concepts that we have leveraged to make sure that our deployment is at a given site is fully high available, as well as portrayed no single point of failure. So in that sense, we have defined a bunch of different host aggregates and primarily 2 different availability zones, both for application servers as well as for database servers. And we defined an array of different size compute flavors, where compute flavors allowed us to place different workloads into different places in that overall blade chassis. Those were very critical from our perspective because, for example, we did not want to land 2 instances, for example, of a given application or of a given database server onto the very same hardware server. Because otherwise, if the hardware server were to fail, we would have, service outage for that particular service. So that's why these concepts were instrumental for us, and those concepts we continue to look for in ensuring the anti-affinity rules that we need for deploying our components. Now, we faced some challenges. A couple of the challenges were strictly brought into place because of the restrictions of the production platforms, such as the second and the third one. Normally, in our labs, we could do any OSM installation where we can just, download and deploy the images for the containers just directly. However, in the production environment, we were not allowed to have public internet access. Therefore, what we had to do for Docker images, for example, was to save them from our lab environment and upload them to this environment, and then start the installation with the no Docker build command, so that we had them readily in place. We also had the intentions of making use of proxy charms. However, we shied away from it in the field because of 2 reasons. One was being slightly sluggish behavior. The second one, more importantly, was our inability to trigger the hooks that were, tied into the charms. So, we had some discussions over Slack, but we were not able to solve this problem. And therefore, we decided to, comment out some of the things we had in our VNF descriptors eventually. Handling live traffic obviously presents its own challenges because this platform and this, what products and services were put into live service, within the year of 2020 at different points in time. So migrating that platform to an NFV-based environment was a challenge in itself in planning and in the operational perspective. One of the most important constraints we had is all the network infrastructure was already predefined. And that includes the external networks, it includes the internal networks and everything else. And the operator had their firewall rules in place to allow these servers and these networks, to be utilized. And we had no room whatsoever, no elbow room for flexibility. So if we had to unplug a particular VNF and to plug in a VM, to plug in a VNF, that's what we had to do in spot. It was very rigid and there was no flexibility. Life would have been much different if we had a greenfield deployment from get-go, where we would be deploying the entire infrastructure and applications in the form of VNFs. However, we did not have that luxury, unfortunately. We had some issues with placement policies, tried to resolve them over Slack. However, we came to the understanding that some of these policies, although with the best intentions they were introduced, they were not being utilized currently. They were not working properly. And also, there were some issues in the way that the dependencies were introduced and dependencies were actually implemented in realizing a particular VNF implementation. We've gone through a little bit of changes per se because of the the modeling, I would say, perspective. There were new things being introduced. We wanted to leverage only the ones that were well proven. We didn't want to operate at the cutting edge. Instead, we wanted to make sure we use the models, we use the APIs, and we use the packaging structures that were well proven through the community by different places. And this is, an ongoing alignment process. We understand and we have tremendous, patience and support for it. But at the same time, when we are doing things in the field, it's kind of difficult even to move a point release, because in the lab environment, you can do pretty much anything, but not in the field. Now, this shows just a brief structure of the SMSC VNF we have. In there, we had 2 different VDUs, and each one of these VDUs could scale at different aspect ratios. And each one of them obviously had connections to a whole bunch of different virtual links. And these connection points, some of them are being external, some of them are being used for OSM management perspective, whereas some others were strictly intended for internal communications. Now, one thing to note, on the side of the screen where I show excerpts from the VNF descriptors, you can see a whole bunch of definitions, declarations in the VNF descriptors being commented out. And the exact reason of what I have mentioned in the former slide, that we originally designed our VNF descriptors to be able to instantiate and realize this network infrastructure as it should be, as if it were a greenfield deployment. However, because of the restrictions, because of the predefined network that we had to use, then we had to comment out all these lines that correspond to different connection points other than the connection point that is used for OSM management perspective. So that is to say, currently, we use the OSM to jumpstart these VDUs, and each one of them have management access to them, and then the rest of the work is left to us as a day 0, day 1, or day 2 configuration to get to. This is just a brief summary of what we had from an initial deployment or from a migration strategy. We had over 10 messaging or VAS applications and about 80 virtual servers, and they were all highly available and active geo-redundant mode of operation. Over time, when we have migrated that, we ended up with around 15 VNF or NS packages. We did not make use of any containerized deployments, and all of them were pretty much VNF based, no physical deployment units either. And we chose to utilize a gradual migration method as opposed to a forklift approach. This is pretty much a snapshot of the migration and the rollback procedure. I'm not going to get into the details, but it suffices to say that we can unplug we could unplug one particular VM and replace it with a VNF, and then configure this particular VNF, and then make it operate in hybrid mode with the existing VM instance. And if things didn't work out, we were in a position to roll back what we have done and restore the original configuration. So that gave us the flexibility of replacing what has been deployed in the form of a virtualized unit into VNF at a speed or at a pace where we deem appropriate. And to achieve that, we essentially made use of very simple scripts, shell scripts, as well as Ansible playbooks. And we operated through two main doors, one being the OSM door, where we could reach to the management interface to the VDU in place or VNF component in place, or alternatively, we could knock on the door of the OpenStack platform to do certain things, such as adding predefined networks, adding predefined volumes, or doing other OpenStack stuff. So, those two doors enabled us to do the day 0, day 1, and day 2 configurations, whether that is the image and the customization of that image and the creation of some basic users or groups as part of the each VNF we are creating as part of the day 0 configuration, all the way up to day 1 configuration, where we have leveraged the day 1 Ansible playbooks to reattach the ports or to connect to the networks that are already defined, or attach the volumes that have been pre-allocated for our use. And then, sure enough, as part of day 2, we have, we could employ scalability policies or any other role-based policy to create additional instances and to leverage the metrics on these created instances and monitor their progress, for sane operations. So finally, we came to this deployment. It is pretty much the same, except that there has been an increase in the NFVI infrastructure capacity from 10 to 18 is where we grew to. And then, we replaced what we had also with an increased number of VDU instances, because all this work has been taking place over a year's time. So in between, there were additional applications being introduced to the platform by us as well as by our partners. However, on the top, we have two different things at the same data centers, obviously, where the NFVI is located for the MANO component. And, we made sure that, one MANO is in charge of one data center, NFV infrastructure, and, the counterpart of it is in the charge of other data centers management functionality. These are some screenshots from the VNFs and NS we have deployed. And finally, I come to a slide where I like to have a few words about what could potentially be done, or what could be done that we would have benefited from. I think we would have definitely benefited from some more of a flexible, whether it's static or dynamic IP assignment procedure. I do understand that this would require some changes in modeling. And I'm not sure if the community has such a need, but I think we get to a point where we really have to be able to in charge of IP address assignment at a VDU instance level. Now, when we make use of the current modeling artifacts such as IP profiles or VM network names. They get us to a certain level. We could make use of some of the, the DHCP-based assignment functionality, etc. However, we were not able to manage it way down to the VDU instance level. The dependency handling in current VNF descriptors is not functional to the best of our experimentation, that they are actually brought into life in the order that they show up in the VNF descriptor. So the depends on structure that we have in the descriptor is really not of any use. However, for us, it's kind of important to get our designated database servers to be up and running before we get our application servers started, for example. So in that sense, the dependency handling is important for us. As I have stated before, the placement functionalities of OSM is crucial to ensure anti-affinity rules that we would like to have in place. And we thought it might be beneficial, especially for newcomers, to have out-of-the-box API collections being supported as part of OSM releases. That way, if for example we built our own Postman collections, and we'll be more than happy to contribute to the community. However, as the standards evolve, as the compliance of the OSM solutions evolve and get more aligned with the upcoming ETSI specs, I think it would be beneficial to have the API collections, the latest form, as opposed to perhaps some deprecated forms of them, to be supported out of the box. And we certainly look forward to faster standards convergence and faster standards alignment. To the best of our understanding, OSM is heavily investing in a Yang-based model, and I am not personally aware of any plans for Tosca-based modeling or packaging support. But if you put yourself into our shoes for a moment, as application developers, as VNF providers, our interest is to deploy our applications as fast as I can, and if possible, using the same VNF packaging that we have built over time, as opposed to having multiple versions of it, one in Yang format, one in Tosca format, which, I really hope that this discussion over languages and the packaging formats actually come to a common ground, and then it gets supported by different vendors all at the same time. And the final bullet item that I have here may or may not be relevant. However, playing around with certain commercial solutions for VNFM and for NFVO, some of them seem to care and be config-driven in the sense that, whether they operate in a grantful mode versus grantless mode. And if you make it grantless mode, essentially the VNFM in itself makes all the decisions without consulting the NFVO. Now, this might be beneficial for the following use case. Since we are making a lot of investment into OSM, it would be great for us to take OSM into multiple commercial opportunities and have it integrate and be used as a generic VNFM against some other NFVO that might be out there. So in that sense, having this kind of control where OSM doesn't necessarily assume the entire responsibility of MANO, but can act as a generic VNFM in this grantless mode or in this grantful mode per se, might be useful, we thought. And that's why there's a question mark next to it. I think this concludes my presentation, and I'd like to take 10 seconds to thank all the entire OSM community and Canonical folks in particular for all the advice, all the suggestions, and all the help that they have given us through the entire OSM technical list, as well as through the Slack community. And I thank you for this opportunity on behalf of the company.
Thanks a lot, Gürol.